Okay, in this problem, in a certain neighborhood, the average price for a home is $65,000 with a standard deviation of $12,750. Assumes the distribution of these prices is bell-shaped. For the following questions, find the z-scores for the prices and then use the empirical rule. First question, A. Approximately what percentage of homes in this neighborhood will be priced between $40,000 and $90,500? Let's go ahead and calculate the z-score. We have a mound-shaped distribution. $65,000 is the average price. That's going to be in the center of the distribution. And it's mound-shaped, so I drew a histogram here to sort of represent a mound-shaped distribution, taking all the prices of the homes in that neighborhood and putting them into a histogram. It would be a mound shape. And then the standard deviation of 12,750. So I know from the empirical rule that approximately 68% of the homes will be within one standard deviation, approximately 95 would be within two, and almost all would be within three. So the first thing I'm going to do in part A is calculate the z-scores of these values and kind of see if they're located in such a way that I can use the empirical rule. Okay, for the 40,000, go ahead and calculate the z-score, subtract the average, divide by the standard deviation. The 40,000 is negative 1.96, so it's negative 1.96 standard deviations to the left of the 65,000. The 90,500 is got a z-score of 2, so it's approximately 2 standard deviations to the right. So I'm going to go ahead and try to mark those. 1 standard deviation, 2 standard deviations, 3 standard deviations to the right, and 1, 2, 3 to the left. And the 40,000 is approximately 2 to the left, and the 90,500 is approximately, or actually 2 standard deviations to the right. So that's kind of where they would fall in that distribution. Knowing that it's a mound-shaped distribution and knowing that almost all the data are within 3, I can put the 90,500 approximately 2/3 the way from the center to the end. It's at the 2 standard deviation mark, 2 out of 3. And then the 40,000 likewise on the left side. So what percentage of the homes would be within 2 standard deviations? The answer for A is approximately 95%. B. What kind of prices can you expect to pay for 68% of the homes in this neighborhood? Well, according to the empirical rule, 68% of the homes will be priced within 1 standard deviation of the mean. So I'm going to add and subtract the 12,000, 1 standard deviation to the mean, 65,000. And I get an interval of 52,250 all the way up to 77,750. So I can go ahead and put these values in the distribution. I've calculated the 1 standard deviation to the left mark and the 1 standard deviation to the right mark. So the answer is just simply that interval. 68% or approximately 68% of the values in the data set will be priced somewhere between $52,250 and $77,750. Okay, part C. Would a home that cost $112,000 be considered an outlier? Anything beyond 3 standard deviations is considered an outlier, so let's just check to see how many standard deviations that 112,000 is away from the 65,000. And if it's more than 3, we've got an outlier. Well, it turns out to be 3.68, so the answer is yes, it is an outlier. And if I could put that in the distribution, it's going to be somewhere out here, 112,000. So yes, it's beyond the normal range of values in the distribution. Okay, part D. What percent of homes will be priced above 90,000? Well, let's check the z-score of the 90,000. Subtract the 65,000 divided by the 12,750, and that is 1.96. So it's approximately 2 standard deviations from the mean. I'm going to round that 1.96 to 2. So it's out here about the 2 standard deviation mark. It's very close to the 90,500. So I'll put it at the 2 standard deviation mark. Again, we're using the empirical rule. It's pretty much all we've got here. So we can only talk about things that are within 1, 2, and 3. So this is approximately 2. I'm going to go with that. Now, what it wants to know is what percentage of the homes be priced above that. In other words, what percent of the values or home prices in this neighborhood would fall in this upper end of the distribution, greater than the 90,000. The key to that, again, is the empirical rule. The empirical rule tells us that at the 2 standard deviation mark, approximately 95% of the home values will fall, somewhere between those two values. Approximately 95% of the homes will be priced between 40 and 90. Now, that leaves 5% of the home prices left. Another thing that's very important about the mountain-shaped distribution is that it's symmetric. If I think of the center of the distribution being at the average, the center here at the average, half of the data values are above it, half the data values are below that value. And also, the distribution is symmetric, that the right side of that is a mirror image of the left side and vice versa. So I've got 5% of homes that are still outside of that 95% middle price interval. So that would mean by symmetry that half of those 5% would fall on the lower end and half on the upper end. So it must be that if you split that, that the lower part and the upper part would be 2.5%. Again, 95% in the middle between the 2 standard deviations marks, and then 5% outside of that. And by symmetry, half that 5% will be on the upper end, half that 5% will be on the lower end. So the answer is 2.5%, approximately 2.5% of the homes will be priced above the 90,000. Now part E, 16% of the homes will be priced under what value? 16% of the homes will be priced under what value? Again, going back to the empirical, which is pretty much all I have here, 68% would be within 1, 95% would be within 2, almost all would be within 3. Let's look at the 68%. 68% of the values would be within 1 standard deviation of the mean. So if I think of all the home prices between the 52,250 and the 77,750, the empirical will say that's approximately 68% of the values. Now, outside of that 68%, what's left is 32%. And because, again, symmetry, that one side of that distribution is a mirror reflection or a mirror image of the other side, half of that 32 will be on the upper end of that middle 68%, and half of the 32 will be on the lower end. Half of 32 is 16%. So, if I look at the 52,000 all the way down to the end of the distribution, that's got to be approximately 16%. 16%. So my answer there is 16% of the homes we price under what value? It'd be under the $52,250 mark. I could also say by symmetry, the percentage of homes above $77,750 is 16%. The percentage of homes above $77,750 would also be 16%. So again, I'm using the empirical rule, and I'm using symmetry of the distribution. And a good idea with a lot of these problems is to draw a picture so you can kind of see what pieces have to go together to get your answer. F says, what percentage of homes will be priced under $77,750? Well, if you look at the picture there, from $52,250 up to $77,750 is 68, approximately 68% of the homes. Below the 52,000, we just calculated at 16%. So if you add those together, it's approximately 84%. Of course, another way you could do it is that half of the homes be priced under 65,000. And then 65,000 is right in the center. So you could take half under 65,000 and then half of the 68, because that 65,000 splits that middle 68%. Take half the 68 and add it to the lower half, and you get 84. Same thing. So there's another way to look at the same problem and answer it. But in these kind of problems, you have the empirical rule. You have a mound-shaped distribution, and the mean is in the middle. Half of the values are below it, half the values are above it. And then you have symmetry, that the right side or the upper part of the distribution is a mirror image of the lower part, and vice versa.